Ascent Audio, a division of Recorded Books, presents HBR Guide to AI Basics for Managers by Harvard Business Review. Narrated by Rich Miller and Cindy Kay. Publisher's Note: this audiobook has bonus material. Please contact whomever you purchase this audiobook from to request the material. All figures and tables referenced in this audiobook can be found in the bonus material. What you'll learn. Artificial intelligence, AI, is having a transformational impact on business. From product design and financial modeling to performance management and marketing spending, AI and machine learning are becoming everyday tools for managers in organizations of all sizes. You can't just leave AI to the experts anymore. If you don't understand the technology at a foundational level, you're not going to be informed enough to make smart decisions that will affect your bottom line. And if you don't realize how AI will change jobs, including the work that managers and leaders do, you may make a major misstep in your career. Whether you want to get up to speed quickly, could use a refresher, or are working with an AI expert for the first time, the HBR Guide to AI Basics for Managers will provide you with the information and skills you need. With practical, applicable advice and plain language takeaways in each chapter, the book will help you take the first steps toward embracing AI and transforming your business. You'll learn how to understand key terms and concepts, including machine learning, training data, and natural language processing. See how automation will change jobs, including your own. Identify the right projects and processes for applying AI tools. Help your employees learn the essentials of AI. Deal with ethical issues and biased results before they come up. Select quality AI consultants and vendors and work with them effectively. Build an AI team that fits your most pressing needs. Communicate better with your machine learning experts and data scientists. Make a plan for when algorithms make inevitable mistakes. Scale AI across your organization. Introduction: How AI Will Redefine Management by Vegard Kolbjørnsrud, Richard Amico, and Robert J. Thomas. Understanding AI and machine learning is no longer just the province of technology consultants, IT departments, and data scientists. Today, every leader and manager should know the practical basics of AI. Fortunately, it's possible for almost anyone to learn the fundamentals of how AI works and what kinds of tasks it does best. To find out how managers can thrive in the age of AI, we surveyed 1,770 managers from 14 countries and interviewed 37 executives in charge of digital transformation at their organizations. Using this data, we identified 5 practices that successful managers will need to master. Leave administration to AI. According to the survey, managers across all levels spend more than half of their time on administrative coordination and control tasks. For instance, a typical store manager or a lead nurse at a nursing home must constantly juggle shift schedules because of staff members' illnesses, vacations, or sudden departures. These are the very responsibilities that the same managers expect to see AI affecting the most. And they are correct. AI will automate many of these tasks. Report writing is another relevant example. The Associated Press expanded its quarterly earnings reporting from approximately 300 stories to 4,400 with the help of AI-powered software robots. In doing so, technology freed up journalists to conduct more investigative and interpretive reporting. Imagine technology like this drafting your next management report. In fact, this is already possible for some analytical management reports. The managers we surveyed see such a change in a positive light. 86% said they would like AI support with monitoring and reporting. Focus on judgment work. Many decisions require insight beyond what artificial intelligence can squeeze from data alone. Managers use their knowledge of organizational history and culture, as well as empathy and ethical reflection. This is the essence of human judgment, the application of experience and expertise to critical business decisions and practices. Managers we surveyed have a sense of a shift in this direction and identify the judgment-oriented skills of creative thinking and experimentation, data analysis and interpretation, and strategy development as 3 of the 4 top new skills that will be required to succeed in the future. As Lane Thompson, Director of ERP Services for a U.S. Navy IT organization, told us, more often than not, managers think of what they're doing as requiring judgment, discretion, experience, and the capacity to improvise, as opposed to simply applying rules. And if one of the potential promises of machine learning is the ability to help make decisions, then we should think of technology as being intended to support rather than replace managers. Treat intelligent machines as colleagues. Managers who view AI as a kind of colleague will recognize that there's no need to race against a machine. While human judgment is unlikely to be automated, intelligent machines can add enormously to this type of work, assisting in decision support and data-driven simulations, as well as search and discovery activities. In fact, 78% of the surveyed managers believe that they will trust the advice of intelligent systems in making business decisions in the future. One company that is trying to access these opportunities is the venture capital firm EQT Ventures, which uses its MotherBrain AI system to assess investment opportunities and identify unknown companies with big potential. The system scans a variety of sources and alerts EQT's investment professionals when it discovers an interesting startup. They, in turn, input their own leads and evaluations into the AI system, training it to better identify and assess leads. EQT strives to frame the software as a friendly and helpful colleague that provides relevant inputs and asks questions at the right time. At EQT and many other firms, AI now serves managers as an always available assistant and advisor. Work like a designer. While managers' own creative abilities are vital, perhaps even more important is their ability to harness others' creativity. Manager designers bring together diverse ideas into integrated, workable, and appealing solutions. They embed design thinking into the practices of their teams and organizations. A third of the managers in our survey identified creative thinking and experimentation as a key skill area they need to learn to stay successful as AI increasingly takes over administrative work. In an interview, Peter Harmer, CEO of Insurance Australia Group, emphasized the need for managers who foster collaborative creativity in the digital enterprise. We need people who can actually layer ideas on ideas. Not somebody who has to win in a competition around ideas, but somebody who can say, "Crikey, if we bring these 2 or 3 or 4 things together, we've got something very, very different." That's the creativity, the curiosity we need in managers. Develop social skills and networks. The managers we surveyed recognized the value of judgment work, but they undervalued the deep social skills critical to networking, coaching, and collaborating that will help them stand out in a world where AI carries out many of the administrative and analytical tasks they perform today. While these managers will use digital technologies to tap into the knowledge and judgment of partners, customers, and communities, they must be able to tease out and bring together diverse perspectives, insights, and experiences. What this book will do for you. AI will ultimately prove to be cheaper, more efficient, and potentially more impartial in its actions than human beings. But such a scenario should not be a cause for concern for managers. It just means that their jobs will change to focus on things only humans can do. Writing earnings reports is one thing, but developing messages that can engage a workforce and provide a sense of purpose is human through and through. Tracking schedules and resources may soon fall within the jurisdiction of machines, but drafting strategy remains unmistakably human. This book will help get you up to speed on topics such as building your AI team, picking the right projects, understanding AI ethics and bias, and scaling AI in your organization. If you're truly new to AI concepts, start with Section 1 and listen straight through. But if you already have a good grasp on the essentials, jump in at any chapter to deepen your knowledge. While oncoming disruptions won't arrive all at once, the pace of development is faster and the implications more far-reaching than most executives and managers realize. Just as technologies such as spreadsheets and visualization tools became must-use apps for managers, simple-to-use AI platforms that require little or no coding will soon be common. Those who are able to assess what the workforce of the future will look like can prepare themselves to thrive in the AI-enabled workplace. They should view it as an opportunity to flourish. Learning about the fundamentals of AI will set you on the right path.
Section 1. AI Fundamentals. Chapter 1. 3 questions about AI that every employee should be able to answer. By Emma Martino Truswell. Articles about artificial intelligence often begin with an intention to shock readers, referencing classic works of science fiction or alarming statistics about impending job losses. But I think we get closer to the heart of AI today when we think about small and mundane ways in which AI makes work just a little easier. And it's not necessarily the AI experts in your organization who will identify these mundane problems that AI can help solve. Instead, employees throughout the organization will be able to spot the low-hanging fruit through which AI could make your organization more efficient. But only if they know what AI is capable of doing and what it should never do. For example, I manage the finances for a team that travels very often, and I've been grateful for the intelligent guesswork that my expenses software extracts from receipts using machine learning. The merchant's name, the dollar amount spent, taxes, and likely expense categorization. Finding opportunities for this kind of clever improvement, saving human time and energy, is not just a leadership challenge. It's a search best undertaken by as many people within the organization as possible. A fast-growing area of artificial intelligence is machine learning, in which a computer program improves its answers to a question by creating and iterating algorithms based on data. It is often regarded as the kind of technology that only the most clever and most mathematically minded people can understand and work with. Indeed, those who work day-to-day building machine learning programs will tend to have postgraduate degrees in computer science. But machine learning is a technological tool like any other. It can be understood on various levels and can still be used by those whose understanding is incomplete. People do not need to know how to fly a plane to be able to spot sensible new airline routes. Instead, they need to know approximately what a plane can and cannot do. For instance, lay people might also have ideas about what planes should not be used for, which could result in positive outcomes, such as reducing aircraft noise in the middle of cities, or limiting costly flights for very short journeys. When leaders in companies, nonprofits, or governments invest in artificial intelligence, much of their attention goes to hiring machine learning experts or paying for tools. But this misses a critical opportunity. For organizations to get the most that they can from AI, they should also be investing in helping all of their team members to understand the technology better. Understanding machine learning can make an employee more likely to spot potential applications in their own work. Many of the most promising uses for machine learning will be humdrum, and this is where technology can be at its most useful, saving people time so that they can concentrate on the many tasks at which they outperform machines. An executive assistant who has a better understanding of machine learning might suggest that calendar software learn more explicitly from patterns that develop over time, reminding them when their boss has not met with a team member for an unusually long time. A calendar that learns patterns could give an executive assistant more time for the human specialties of the job, such as helping their boss to manage a team. So, what should all of your employees be learning about AI? Here are 3 important questions that any member of your team should be able to answer. How does it work? Team members who aren't responsible for building an AI system should nonetheless know how it processes information and answers questions. It's particularly important for people to understand the differences between how they learn and how a machine learns. For example, a human trying to analyze 1 million data points will need to simplify the data in some way in order to make sense of it, perhaps by finding an average or creating a chart. A machine learning algorithm, on the other hand, can use every individual data point when it makes its calculations. They are trained to spot patterns using an existing set of data inputs and outputs. Because data is fundamental to a machine's ability to provide useful answers, a manager should ensure that their team members have some basic data literacy. This means helping people to understand what numbers are telling us and what biases and errors might be hidden within them. Understanding data, the fuel of AI, helps people to understand what AI is good at. What is it good at? Machine learning tools excel when they can be trained to solve a problem using vast quantities of reliable data and to give answers within clear parameters that people have defined for them. My Expenses software is a perfect example. It has the receipts of its millions of users to learn from, and it uses them to help predict whether a cup of coffee from Starbucks should be categorized as travel, stationery, or entertainment. Learning what machine learning is good at quickly helps someone to see what machine learning is not good at. Problems that are novel, or which lack meaningful data to explain them, remain squarely in the realm of human specialties. Help your employees to understand this difference by showing them tools they already use that are powered by AI either within the organization or outside it, such as social media advertising or streaming service recommendations. These examples will help team members to understand AI's enormous potential and also its limitations. What should it never do? Just because machine learning can solve a problem does not mean it should do so. A machine cannot understand the biases that data reveals, for example, nor the consequences of the advice it gives. There may be some problems that your organization should never ask an AI application to solve. For example, I would not want an algorithm to make the final decision for my company on whom to hire, what to discuss at a board meeting, or how to manage a poorly performing staff member. If employees have thought about proper ethical limitations of AI, they can be important guards against its misuse. The organizations that will do best in the age of artificial intelligence will be good at finding opportunities for AI to help employees do their day-to-day jobs better, and will be able to implement those ideas quickly. They will be clear about where to deploy machine learning and where to avoid it. Alongside their investments in technology, they will remind their teams of the importance of human specialties, supporting colleagues, communicating well, and experimenting with novel ideas. To be ready for pervasive AI, an organization's whole team will need to be ready too.
Chapter 2. What Every Manager Should Know About Machine Learning by Mike Yeomans. It seems as though every week companies are finding new uses for algorithms that adapt as they encounter new data. As managers navigate these advances, it is helpful to think of machine learning simply as a branch of statistics, designed for a world of big data. Those who want to get the most out of their company's data should understand what it is, what it can do, and what to watch out for when using it. Not just big data, but wide data. The enormous scale of data available to firms can pose several challenges. Of course, big data may require advanced software and hardware to handle and store it. But machine learning is about how the analysis of the data also has to adapt to the size of the data set. This is because big data is not just long, but wide as well. Consider an online retailer's database of customers in a spreadsheet. Each customer gets a row, and if there are lots of customers, then the dataset will be long. However, every variable in the data gets its own column too, and we can now collect so much data on every customer, purchase history, browser history, mouse clicks, text from reviews, that the data is usually wide as well, to the point where there are even more columns than rows. Most of the tools in machine learning are designed to make better use of wide data. Predictions, not causality. The most common application of machine learning tools is to make predictions. Here are a few examples of prediction problems in a business. Making personalized recommendations for customers. Forecasting long-term customer loyalty. Anticipating the future performance of employees. Rating the credit risk of loan applicants. These settings share some common features. For one, they are all complex environments, where the right decision might depend on a lot of variables, which means they require wide data. They also have some outcome to validate the results of a prediction, like whether someone clicks on a recommended item or whether a customer buys again. Finally, there is an important business decision to be made that requires an accurate prediction. One important difference from traditional statistics is that you're not focused on causality in machine learning. That is, you might not need to know what happens when you change the environment. Instead, you are focusing on prediction, which means you might only need a model of the environment to make the right decision. This is just like deciding whether to leave the house with an umbrella. We have to predict the weather before we decide whether to bring one. The weather forecast is very helpful, but it is limited. The forecast might not tell you how clouds work or how the umbrella works, and it won't tell you how to change the weather. The same goes for machine learning. Personalized recommendations are forecasts of people's preferences, and they are helpful, even if they won't tell you why people like the things they do or how to change what they like. If you keep these limitations in mind, the value of machine learning will be a lot more obvious. Separating the signal from the noise. So far, we've talked about when machine learning can be useful. But how is it used in practice? It would be impossible to cover it all in one article, but roughly speaking, there are three broad concepts that capture most of what goes on under the hood of a machine learning algorithm. Feature extraction, which determines what data to use in the model. Regularization, which determines how the data is weighted within the model. And cross-validation, which tests the accuracy of the model. Each of these factors helps us identify and separate signal, valuable, consistent relationships that we want to learn, from noise, random correlations that won't occur again in the future which we want to avoid. Every data set has a mix of signal and noise, and these concepts will help you sort through that mix to make better predictions. Feature extraction. Think of feature extraction as the process of figuring out what variables the model will use. Sometimes this can simply mean dumping all the raw data straight in, but many machine learning techniques can build new variables, called features, which can aggregate important signals that are spread out over many variables in the raw data. In this case, the signal would be too diluted to have an effect without feature extraction. One example of feature extraction is in face recognition, where the features are actual facial features, nose length, eye color, skin tone, etc., that are calculated with information from many different pixels in an image. In a music store, you could have features for different genres. For instance, you could combine all the rock sales into a single feature, all the classical sales into another feature, and so on. There are many different ways to extract features, and the most useful ones are often automated. That means that rather than hand-picking the genre for each album, you can find clusters of albums that tend to be bought by all the same people and learn the genres from the data. And you might even discover new genres you didn't know existed. This is also very common with text data, where you can extract underlying topics of discussion based on which words and phrases tend to appear together in the same documents. However, domain experts can still be helpful in suggesting features and in making sense of the clusters that the machine finds. Clustering is a complex problem, and sometimes these tools are used just to organize data rather than make a prediction. This type of machine learning is called unsupervised learning, because there is no measured outcome that is being used as a target for prediction. Regularization. How do you know if the features you've extracted actually reflect signal rather than noise? Intuitively, you want to tell your model to play it safe, not to jump to any conclusions. This idea is called regularization. The same idea is reflected in terms like pruning, shrinkage, or variable selection. To illustrate, imagine the most conservative model possible. It would make the same prediction for everyone. In a music store, for example, this means recommending the most popular album to every person, no matter what else they liked. This approach deliberately ignores both signal and noise. At the other end of the spectrum, we could build a complex, flexible model that tries to accommodate every little quirk in a customer's data. This model would learn from both signal and noise. The problem is, if there's too much noise in your data, the flexible model could be even worse than the conservative baseline. This is called overfitting. The model is learning patterns that won't hold up in future cases. Regularization is a way to split the difference between a flexible model and a conservative model, and this is usually calculated by adding a penalty for complexity, which forces the model to stay simple. There are two kinds of effects that this penalty can have on a model. One effect, selection, is when the algorithm focuses on only a few features that contain the best signal and discards the others. Another effect, shrinkage, is when the algorithm reduces each feature's influence, so that the predictions aren't overly reliant on any one feature in case it turns out to be noisy. Cross-validation. Once you have built a model, how can you be sure it is making good predictions? The most important test is whether the model is accurate out of sample, which is when the model is making predictions for data it has never seen before. This is important because eventually you will want to use the model to make new decisions, and you need to know it can do that reliably. However, it can be costly to run tests in the field, and you can be a lot more efficient by using the data you already have to simulate an out-of-sample test of prediction accuracy. This is most commonly done in machine learning with a process called cross-validation. Imagine we are building a prediction model using data on 10,000 past customers, and we want to know how accurate the predictions will be for future customers. A simple way to estimate that accuracy is to randomly split the sample into two parts: a training set of 9,000 to build the model, and a test set of 1,000, which is initially put aside. Once we've finished building a model with the training set, we can see how well the model predicts the outcomes in the test set as a dry run. The most important thing is that the model never sees the test set outcomes until after it is built. If you don't keep a clear partition between these two, you will overestimate how good your model actually is, which can be a very costly mistake to make. Mistakes to avoid when using machine learning. One of the easiest traps in machine learning is to confuse a prediction model with a causal model. Humans are hardwired to think about how to change the environment to cause an effect. In prediction problems, however, causality isn't a priority. Instead, we're trying to optimize a decision that depends on a stable environment. In fact, the more stable an environment, the more useful a prediction model will be. It's important to draw a distinction between out-of-sample and out-of-context. Measuring out-of-sample accuracy means that if we collect new data from the exact same environment, the model will be able to predict the outcomes well. However, there is...
Sample complete. Ready to continue?